Okay, so finding the domain of this, like I said, you know that it cannot be 0. So find the domains of each of those, which I did. So where do they overlap? They overlap everywhere but at 0. That's where they overlap at. They overlap at everywhere but 0. So it says find f plus g of x. So it says to add f and g together. So f of x is 3x and g of x is 1 over x. So I have to find common denominator, so the common denominator is x for both of these. So I get x over 4 plus 1 over x, and remember x cannot equal 0. So it'll go from negative infinity to 0, and with a circle bracket at 0, union, circle, curve bracket 0 to infinity, because it cannot equal 0. So that's where they overlap at. Subtraction will be identical. The problem will literally be identical, except it's x to the fourth minus 1. Still the same thing applies. That's going to be that it cannot be 0 again, but this says, hey, plug in 2x. So then everywhere where there's an x, I'm going to plug in a 2x. That's the only difference. So that's 2 to the fourth, x to the fourth. Well, 2 to the fourth is 16x to the fourth minus 1 over 2x. Same rule applies, set it so it does not equal to 0. When you divide it by 2, you still get that it can't equal 0 as well. When you multiply these two together, we multiply them, but now it wants us to plug in a 5. So when you plug in a 5 there, you end up getting 5 squared, which is 25. But remember, you can't put a 0 in for x there, or it won't work. That'll be 0 or undefined. And then just divide the two, f of g of x. Well, 1 over x cubed divided by 1 over x, that cannot equal 0. So whatever's in the bottom cannot equal 0. Well, what's on the bottom there is this, and that can't equal 0, because if that equals 0, then the whole thing will be undefined. So you actually flip it because it's two fractions, so you multiply by the reciprocal, so it's actually x to the fourth. But still remember, the domain, it cannot be 0, so you still can't plug 0 in. Just like in this problem, you still could not plug 0 in, or it would not give you an answer. If you have any questions or concerns, please email me or please let me know. Thank you.